Hello again. In this video we're going to look at constant expressions. A constant expression has a value which is evaluated at compile time and which cannot be changed. So obviously literals would be constant expressions. We can also have values which are computed entirely from literals, and we can have values which are computed from other constant expressions. So if you have a constant expression, it's basically some computation involving literals. We can also have a variable which is a constant expression. For this, the variable has to be initialized from a constant expression, and the variable cannot be modified after being initialized. For example, 42 and 99 are literals, so they are constant expressions. I and j are initialized from constant expressions, and they cannot be modified after initialization. So I and j are constant expressions. Then I plus j is a computation involving only constant expressions, so I plus j is therefore a constant expression. So this means you could use I plus j as the dimension of an array, because the dimension of an array must be a constant expression. If we make I and j non-const, then they are still initialized from constant expressions, but they can now be modified after being initialized. So I and j are not constant expressions, and this will give a compiler error, unless you're using G++, when you have to use the minus pedantic option, because G++ allows this as a non-standard extension. So here's the code. We have I and j initialized from 42 and 99, which are constant expressions. I and j cannot be modified after initialization, so they're constant expressions as well. And then I plus j is a constant expression and can be used for the dimension of an array. And then that compiles. We just get a warning about the unused local variable. If I make I and j non-const, then they are no longer constant expressions because they can be modified after initialization. And then I plus j is not a constant expression, and we get an error. Did not evaluate to a constant. So let's look a bit more closely at what it means for something to be const. The const keyword has been around since the early days of C++. A variable which is const cannot be modified after being initialized. There are two ways to initialize a const variable. We can use a constant expression. So we have something like this. So I is actually a constant expression. We can also initialize a const variable from a value which is known at runtime, because const just means you cannot change the value. So we could, for example, read something from the keyboard and then use that to initialize a const variable. If we're talking about compile time programming, which is the subject of this section, then this could be interesting because the compiler will know the value of I. On the other hand, this is no use because compilers have no way of knowing what users are going to do when the program runs. So we have two separate concepts here, and in C++11 we have a new keyword for the constant expression concept. So the const Exper keyword means that a variable is a constant expression. This means that the variable is evaluated at compile time and cannot be modified. So with the variable I, which we declared as constant before, we can now declare this as const Exper, because I is a constant expression. So what are the differences between being const and being const Exper? A variable which is const cannot be modified, and this is mainly used for function arguments. We pass an argument by reference to const or pointer to const for efficiency and safety, and the compiler will make sure that the function cannot modify the argument. If we have a variable which is const Exper, this means the value is known at compile time and cannot be modified. And we use that for computing the value of constants. And this is useful because we can improve performance by doing calculations at compile time instead of when the program runs. Okay, so that's it for this video. I'll see you next time, but until then, keep coding.